now we get to do triple integrals. So with some of these, the integral is already going to be set up for you. For ones like this, I'm going to go through it a little bit faster. There's ones where you have to set up the integral, and that is going to take a little more work, and I'll slow down for those. So this is saying integrate with respect to y first, second integrate with respect to z, and last integrate with respect to x. So this is basically saying it came from the graph where y equals x plus z, and also y equals 4. So those are two planes, and the y values are going between those two planes. So to actually do it, this is going to be, the antiderivative is going to be y, and then that gets evaluated from x plus z to 4, and then just recopy the dz dx. So basically that means it's going to be the top plane minus the bottom plane. So substituting in, that's going to be 4 minus x plus z. And then we need to integrate with respect to z next. And last, integrate with respect to x. So integrating with respect to z means this is going to be 4 times z. This one will be negative x times z, because just like the 4, right now x is a constant. And then this will be z squared over 2, but don't forget to distribute the negative. And then this gets evaluated with z going from 0 to 4 minus x. Substitute for all of these z's, substitute a 4 minus x. And last, we need to integrate with respect to x. So let's see, I should probably do a little bit of algebra before I integrate. So this would be 16 minus 4x. This would be a negative 4x and then plus an x squared. And with this one, I'm just going to integrate it by itself. So this will be integral from 0 to 4, and then combining like terms, there's going to be 16 minus an 8x plus an x squared minus this 4 minus x being squared over 2. Okay, last, integrate with respect to x. So this will be 16x. This one will become x squared over 2, which is going to make this a 4. And then x cubed over 3. And the way that I integrated this one, that's how I'm going to integrate this one. So add 1 to the exponent, that would be 3, and then divide by 3. And then you have to consider the chain rule. The derivative of the inside would be a negative 1, so also divide by a negative 1, which will actually change this to a positive. And finally, evaluate that from 0 to 4. So when you substitute the 4, that's going to be 16 times 4 minus 4 times 4 squared plus 4 cubed over 3. And when you substitute a 4 in here, this is going to be 0. Okay, then minus, when you put a 0 in, that's 0, that's 0, that's 0, and then this would be 4 minus 0, so it's 4 cubed over 6. So how much does all of that equal? So we've got 16 times 4 minus 4 times 16 plus 4 is cubed divided by 3, and then minus 4 is cubed divided by 6. And the grand total is 10 2/3, or 10.667. All right, then for example number 2, see, I prepared, I did my homework. Find the volume between these two paraboloids. So this one got shifted up by 8, and because of the negatives, it's upside down. So that's the red one. So up here is an 8. And then it's opening down like this. And this is a paraboloid that starts at the origin and then is opening up. So that's this one right here. And then they meet right here. So this is both red and black, this little circle right here. And for this one, just set up the integral. Okay, so for the volume. So the z value is going to go from the bottom paraboloid until it goes up to the top. So for finding volume, it would be a triple integral, and then it's going to go dx, dy, dz, or whatever order, but it's going to just be the dx, dy, dz, or dz, dy, dx. There's not going to be any extra function. So with this one, I'm going to put the z first, dz, and then after that, I'll go dy, and then dx. I definitely want to do dz first because I can see that the z values have to go from the bottom paraboloid to the top paraboloid. So it has to go from the bottom one, and that's where z equals x squared plus y squared, to the top one, 8 minus x squared minus y squared. Now, what about x and y? Well, right here is where they meet. And basically, we have to have x values that will go to here so that it can go up to where they meet right there, all the way until right here when they meet right there. That way, all of these x values will take care of all of this part over here. Likewise, the y values are going to have to range from, say, 0 right here. Well, that will take you to the middle of it, until you get out to some point right here where you go up, and it's going to give you that point right there. Well, what we could do is take this picture and then drop it down onto the xz plane. Another way to look at that is right here, that's where the two of these paraboloids, that's where the two paraboloids meet. That means that's where this one equals this one. So where does 8 minus x squared minus y squared equal x squared plus y squared? Notice that this has no z's in it anymore, basically because we're done with z for one thing. For another thing, what this is doing is it's taking this circle right here and it's dropping it down onto the xz plane by doing this algebra right here. Now, add x squared to both sides. They're then going to be 2x squared. Add this y squared to both sides, so that's going to be 2y squared, and then it still equals 8. Or you could divide everything by 2. So that means that this circle right here is the circle x squared plus y squared equals 4. It happens to be sitting up here in the sky, but we don't really need it sitting up in the sky. We could look at it just in the xy plane. So that's this circle, and it's got a radius of 2. So now what does y do? So the y value would go from, at some given point, the y value is going to go from the bottom of the circle to the top of the circle. So I should have left more space. Let me just rewrite it with more space. So this part is x squared plus y squared. This is 8 minus x squared minus y squared. And then right here, I need to solve for y. So in this equation, then solve for y. So this would be y is equal to the square root of 4 minus x squared. And this one would be when you take the square root and you put the negative in front of it. So y equals negative the square root of 4 minus x squared. So it's going to go from negative the square root of 4 minus x squared to the positive square root of 4 minus x squared. And then finally, if you're going to get a number for the volume, then the last integral has to just be a number and a number, not a function. So then what does x range from and to? So at the very smallest, x is going to be negative 2 over here. And at the very biggest, x is going to equal positive 2 over here. So it goes from negative 2 to positive 2. And then this one is set up. Now for something like this, it would actually be better to use polar form if we were going to actually integrate it. With this one, it was just set it up. So I'm actually done with number 2. But if I was going to integrate this, I would change it to polar form. It would be much easier to integrate in polar form. All right, then for example number 3, and I literally looked at the homework and made up problems that were very similar. So for this one, integrate with respect to z first of all. So that means that this is held constant, so the integral will be x squared times z. And this one will be z cubed over 3. And then that gets evaluated from 0 to 2. And then later dy and later dx. All right, so first of all, substitute the 2. So this will be 2x squared, and this will be 8/3. So you've got 2x squared plus 8/3. And when you substitute the 0, that's going to be 0, and that's going to be 0. So this is all that remains. And then integrate with respect to y, and last integrate with respect to x. So integrating with respect to y means that all of these are constant. So the antiderivative right here will be 2x squared times y plus 8/3 times y. And then that gets evaluated from 0 to 1. So when you substitute a 1 for y, this is just going to be 2x squared, and this will just be 8/3. And when you substitute the 0, that's 0 and that's 0. So the last thing to do is integrate with respect to x. The antiderivative right here is going to be x cubed over 3, so there's going to be 2x cubed over 3 plus 8/3 x. Evaluate that from 0 to 3. So this is going to be 2, and then 3 gets cubed over 3 plus 8/3 times 3. And once again, thank goodness for the zeros, cuts my work in half. That's 0 and that's 0. So let's see, this would be 27, but if you divide it by 3, that's 9, which means this is 18. And here these 3's are going to cancel, so it's just plus an 8. And then that equals 26. And now for example number 4. First, we integrate with respect to z, which means that these are constants, so they just stay there. And then times z, which is evaluated from 0 to x. wish I could just automatically bring these things down and not have to write it every time. Okay, enough of my complaining. Now it's z that we're substituting in, so this will become an x, and then when you substitute 0, it contributes nothing. So if this is an x, that means this actually becomes x squared times sine of y, and then integrate with respect to x, and finally integrate with respect to y. So integrating with respect to x means that this is x cubed over 3 times sine of y. That gets evaluated from 0 to 4. When you substitute the 4, that's going to be 4 cubed over 3 times sine of y. And once again, a 0 is going to contribute nothing. So we're just left with this 4 cubed over 3 sine of y, and then integrate that with respect to y. So the antiderivative of sine is going to be negative cosine. And then evaluate from 0 to pi. So that will be negative 4 cubed over 3 cosine of pi minus negative 4/3 over 3 cosine of 0. Now cosine of pi, that's equal to negative 1. So that means that that negative 1 times that leaves a positive 4 cubed over 3. And cosine of 0 is equal to 1. That means this is negative times negative is positive 4 cubed over 3. So finally we have two of them that are 4 cubed over 3. Or if we need a decimal, how much is that? So 2 times 4 is cubed over 3. So 42.667 in case a decimal is needed. Then for number 5, so this one I saw in the homework and I thought, oh, that one's cool because it's got x, y, and z, x, y, and z, and all of these are the same. That looks interesting. I'm going to do that. So to begin with, integrate with respect to y. So this would be like integrating sine of x plus 5 because the y and the z are constant. So the antiderivative of sine, that is negative cosine. And the derivative of the inside, if you pay attention to the chain rule, the derivative of the inside would be 1. So this needs to be divided by 1. There, I did it. I divided by 1. Now evaluate from 0 to pi over 2. So the antiderivative of, oh sorry, I was skipping ahead. I still need to plug in the numbers. So substituting for x, the pi over 2, this is going to be negative cosine and then pi over 2 plus y plus z, and then minus this, and if you're minusing a negative, it becomes plus cosine, and then put a 0 right here for x, which means it leaves y plus z. And then, because of this plus in between, I can't really simplify it, so I'm just going to go ahead and integrate with respect to y. So the antiderivative of negative cosine, that will be negative sine and the antiderivative of positive cosine will be positive sine. And then that gets evaluated as y goes from 0 to pi over 2. So I have a feeling we're just going to get cosine with a bunch of pi over 2's. Let's see. So now substitute that y is a pi over 2. And I'm actually going to need some more space. So we'd have negative sine, and then the y is going to become pi over 2. So it's going to be pi over 2 that was already there, plus another pi over 2, plus z. And then this one, substitute a y over 2 right here. Did I say y over 2? Because I combined those two. Pi over 2 for y. And now what about the 0? So then minus this thing. So that actually means plus. And now put a 0 right here for the y. So that'll be sine of pi over 2 plus z. And then minus also this one, which means it's going to be negative sine. And then put the 0 for y, so it's just going to be sine of z. And good thing we're down to the last one, because I don't know if I could fit any more on the page. Okay, now integrate with respect to z. So let's see, they all have a z, so that means I do need to integrate each and every one of them. The antiderivative for negative sine, that's going to be cosine. So these two I can combine, that makes pi plus z. Let's see, the antiderivative for positive sine is negative cosine. The antiderivative for positive sine, that's going to be negative cosine. Oh, I guess I could have just combined those, couldn't I? Because it says the same thing. So it's the same thing showing up twice. So actually I have 2 of these. So that takes care of those. And then for this one, that's going to be cosine of z. And then evaluate that from 0 to pi over 2. So this is going to be a pi over 2. So we'll have cosine and then a pi plus a pi over 2. That means 1.5 pi's. That means 3 pi over 2. Minus 2 of them that say cosine. And then substitute the pi over 2. So half of a pi plus a half of a pi equals a whole pi. And then this will be minus cosine of pi over 2. And now use the 0. So then minus this with a 0 right there. So that means minus cosine of pi. And then minus this one, which is actually going to make it plus 2. And since the z is 0, it's going to be cosine of pi over 2. And then finally, minus this one, which means plus cosine of 0. Whew, that was a bit of a workout. Okay, now what's the final answer? So I guess I could use a calculator, but I could also use, here's the cosine graph. This is 2 pi. This is pi. Right here's pi over 2. And right here is 3 pi over 2. So cosine of 3 pi over 2, that equals 0. Cosine of pi, that equals negative 1. So this is going to be negative 1 times negative 2, so that's going to be a positive 2. Cosine of pi over 2 is 0, so this one's going to say minus 0. Cosine of pi, that's negative 1, so negative 1 times negative 1 will be positive 1. Here's another cosine of pi over 2, so that's 0. And then finally, cosine of 0, that's equal to 1, so add in another 1. So finally, it's 2 plus 1 plus 1, 4. Okay, now for example number 6. So this is a plane, and this is a plane. Find the volume between those. in octant 1? Well, octant 1, first of all, means over here, x is positive, over here, y is positive, and up there, z is positive. So in other words, x is bigger than or equal to 0, y is bigger than or equal to 0, and z is bigger than or equal to 0. So this is the first octant. So we're only finding that part right there. Now, I went to GeoGebra. I don't think it's worth switching over to the video, but I went to GeoGebra and I graphed it. And this down here is octant 1. So it's talking about this volume in here. So it's sort of a triangular volume. And I need to know z goes from this plane up to this plane. So which one is the top plane and which one is the bottom? So that's the first thing to do. And you don't actually have to graph it to figure that out. For one thing, what I'm going to do on each one of these is solve for z. So for this one, subtract the x and the y, also divide by 4. So that's going to say z equals 5, subtract x, subtract y, divide everything by 4. And then for this one, all you need to do is subtract 3x and subtract 3y. So z is equal to 15 minus 3x minus 3y. Now, which one of these was the top plane? So let's say you go to this point right here, where x equals 1 and y equals 1. So just take that point, 1 and 1, plug it into each one, and see which one creates the bigger z value. So for this one, it would be z equals 5 minus 1 minus 1 over 4. So what's that? 5 minus 2, so that's 3/4. For this one, plug in the same point, 1 and 1 for x and y. This one will be 15 minus 3 minus 3. So that's 9. 15 minus 6 is 9. So it turns out this is the top one. And if you do look at the picture, so this is the top one. And right about here, I know this isn't a great picture, but right about here, it looks like it's hitting at 15. Because if x equals 0 and y equals 0, it's going to hit the z-axis at 15. So this is the top one. This is the bottom one. Okay, now I'm ready to start setting up the integral. So I'd have finding volume means triple integral. And I was working with the z first, so this is going to be dz, and then I'll decide on the other two in just a moment. And this has to be the bottom one, so this is 5 minus x minus y over 4. And this one is 15 minus 3x minus 3y. So that's the z part. Now, what about dx and dy, or dy and dx? Back to this little picture right here. So like I said, over here is the first octant. This is y is positive, this is the x is positive, and you could see the planes meet right here. So then I need to know what's that line. So that is in the xy plane, so that means that that z is equal to 0, and then it's a line that has just x and y. Or if you rotate the picture a little bit, so this is the x-axis, this is the y-axis, and then I told it, draw the line where the two intersect, and that's this line right here. And again, you don't have to graph it. Calculus has been done for hundreds of years without GeoGebra, so it's possible to do it without GeoGebra. So those two planes intersect somewhere. So if this is equal to z and this is equal to z, then just put this one equal to this one. So what we'll need to do is do some algebra over here. So where does, and it looks like I need a new pen. 5 minus x minus y over 4. Where does that equal 15 minus 3x minus 3y? I don't really want this fraction, so I'm going to multiply both sides by 4. So 5 minus x minus y, then multiply by 4, so that would be 60 minus 12x minus 12y. And then, let's see, I think I'm going to take these and I'm going to add them to the other side, and I'll take the 5 and move it to the right side. So let's see, if you add 12x, on this side it'll become a positive 12x minus 1, so that's an 11x. And the same thing happens with the y's. And then subtract 5 from both sides, so this is going to be 55. Or, with this, you could actually divide everything by 11. That will reduce nicely. So, that line that I was just looking at is the line x plus y equals 5. And I don't know if you can see it, but right there, that's y equals 5, and I can't even see that one. I can see that says 4.5 and that says 5.5, so that is 5. So it looks like my algebra is correct. So that means I'm going to do dy, and so basically I can now just look at the xy axis, and if x equals 5, then y equals 0. And if y equals 5, then x has to equal 0. So this is the line that I was just showing you on that scrap of paper. And then this is the line, y equals 5 minus x. So because we're in the first octant, I don't need to continue it into any negatives. I don't need to be over here, just need to be in this first quadrant. So that means that the y value is going to go from 0 up to 5 minus x. So for this limit, dy is going to go from 0 to 5 minus x. And then finally, what about x? Well, since we're talking about the first quadrant, and everything has to stay positive or bigger than or equal to 0, it has to go from 0 to 5. Okay. Now, we did the hardest part, which is setting up the integral. Now for the fun part, actually integrating. Okay, so integrate with respect to z. So this just becomes z, and then it's evaluated from the bottom is 5 minus x minus y over 4. The top is 15 minus 3x minus 3y. And then this is integral from 0 to 5 minus x, and this is integral from 0 to 5. So that means it's going to be the top one minus the bottom one. So the top one, 15 minus 3x minus 3y, and then minus the bottom one, and then dy, and then dx. So I don't want to deal with this fraction. Much like over here in this algebra, I didn't want to deal with the fraction, so I multiplied on the other side, and this became 60 minus 12x minus 12y. I'm going to do the same thing right here, but I cannot multiply by 4 because there is no other side of the equation. You would have to multiply both sides of an equation. But what I can do is factor out a 4. So I'm going to factor out a 1/4, I meant to say. Factor out this 1/4 right here. which means you have to divide this by 1/4 also. That's the same thing as multiplying it by 4. So that's going to be the 60 minus 12x minus 12y. And you could check it because if you distribute this 1/4, 1/4 of 60 would be 15. 1/4 of negative 12 will be negative 3x, etc. And this one got factored out. So all that's left is minus, and I do need to distribute the negative. So minus 5, and then plus 11x. 11, where did I get that? Hold on. So I rarely do this on camera, but I'm not going to redo it just because of that. Okay, so negative negative will be plus an x, and then negative negative will be plus a y. Then dy, then dx. I suppose that I should combine like terms. So there's going to be 60 minus 5, so that's 55. There will be negative 12x and positive 1, so that's negative 11x. And negative 12 and 1 is negative 11y. And then we'll integrate that from 0 to 5 minus x. And last will be integrate from 0 to 5. And don't forget the 1/4 that got factored out. So integrating with respect to y means this one is 55y minus 11x times y minus an 11y squared over 2. And that gets evaluated from 0 to 5 minus x. So all of these y's right here are going to become 5 minus x. So we'd have 55 times 5 minus x minus 11x times 5 minus x, and minus 11, 5 minus x squared over 2. Now substitute 0. And right now this is y equals 0, which means that's a 0, that's a 0, and that's a 0. Oh, thank you for the 0. Now we still need to integrate from 0 to 5 and multiply it by 1/4. So right now I either have the choice of multiplying this whole thing out, or I could factor. Oh, but the problem is if you factor, then you would have a function of x times another function of x, which means we'd have to do integration by parts, that's making it even harder than we need to. It would be better to just go ahead and multiply it out. Just go for the pain. All right. So multiplying this out is going to be 275 minus 55x. And then this would be minus 55x. And then this would be plus 11x squared. And then this one, I think you've seen me do before that I'm not going to multiply out that square. I'm just going to integrate this one just as it is. Okay, so I'm ready to do the antiderivative. So the antiderivative here will be 275x. Combining these makes negative 110x. So that'll be negative 110x squared over 2. And this one would become 11x cubed over 3. And then for this one, so much like this, it's going to become cubed over 3. So there's going to be the negative 11, and then 5 minus x cubed over 3. So if you put another 3 down here, it's now going to be over 6. And then evaluate that from 0 to 5. Substituting the 5 means that we have 275 times 5 minus 110 divided by 2, that's 55, times 5 squared, plus an 11 times 5 cubed over 3. And when you substitute a 5 in here, this is 0. Okay, now minus when you substitute the 0. So that's 0, that's 0, that's 0, and that would be 5 minus 0. Now remember, we have to subtract this when you substitute this limit. So if you're subtracting this, oh, hold on, I missed something right here. When I integrated, I forgot the chain rule. The chain rule would be the derivative inside is a negative, so then you have to divide by a -1, so this actually should have said plus right here. Okay, so I did the first limit and then minus the second limit. So it's going to be minus this, so minus 11, and then 5 is cubed divided by 6. I think this is the longest problem that I've done so far this semester. One quarter. And then 275 times 5 minus, that's not a minus, minus 55 times 5 squared, and then plus an 11, and 5 gets cubed, and that's divided by 3, and then minus 11, and 5 gets cubed, and that gets divided by 6. And it equals 57.292. And then I just want to show you that to make sure I got that one right, I worked it out right before class, and I got the same thing. So that's finally it.